In this video, we will discuss computer simulation in Excel. Simulation is a useful tool in business that can be used to incorporate uncertainty into spreadsheet models. In a simulation model, some cells contain random quantities, and each time the spreadsheet recalculates, new values of random quantities are generated, and this leads to different bottom line results. In Excel, in order to generate our random quantities, we can use the random function. The random function generates a random number between 0 and 1. The numbers that are generated are said to be uniformly distributed between 0 and 1. This is because any decimal value between 0 and 1 is possible and equally likely to be generated. The rand function can also be used as part of another function. This is very useful in business because managers are then able to discover results that are most likely to occur or least likely to occur, and they're also able to identify the best and worst case results. So in this example, we are going to use the random function as well as the NORM.INV function. If you're interested to learn more about the norm inverse function, please take a look at this video that I have uploaded earlier. I will insert the link right here. So let's get started with our example. Company A is a retailer that sells a special type of pen. The company wants to model its demand for pens over the next 12 years. Company A assumes demand in year 1 is uniformly distributed with a mean of 4,500 and standard deviation of 1,200. It assumes that demand in each year is normally distributed with a mean equal to the actual demand from the previous year and standard deviation remaining the same as 1,200. For instance, if demand in year 1 is 4,000, then the mean in the second year becomes 4,000. Using this information and Excel's norm inverse function, construct a spreadsheet model for pen demand over the next 12 years. So in order to get started with this example, let's just summarize the information. Demand in year 1, the mean is 4,500, standard deviation is 1,200. Now in year 2, as per the question, mean becomes the demand value from year 1, and standard deviation remains the same at 1,200. So let's get started and use the norm inverse function in Excel to generate our demand for the next 12 years. So let's get started with our demand calculation. So let's start typing equals to norm, and when you see the norm inverse function, just double click on it. The first argument in the function asks for probability. Here we're going to make use of the random function. So we're going to type RAND, and when you see the function, just double click on it. For the random function, you don't have to put anything in the brackets, just close the bracket as is. So Excel will randomly generate our probabilities. Comma, mean for year 1 is equals to 4,500, comma, standard deviation is 1,200. Let's close bracket, press enter. Now, for year 2, in order to calculate demand, as per the question, mean is the actual demand generated in year 1. So let's build our function. So for year 2, it's going to be equals to norm inverse probability. You're again going to use the random function, and in place of mean you can do cell referencing, comma, standard deviation is 1,200. So at this point here, if you want, you can absolute reference your value and close bracket. For year 3, since we did cell referencing in the formula for year 2, we can drag and drop the formula to the other cells. Now, because we're using the random function, every time you press enter, on the cells, the random values tend to change. So let's drag and drop till year 12. Now let's double check to see if the formula looks correct. So for year 3, we inserted the second year's value for mean, and standard deviation remains the same at 1200. And you're still using the random function. Now let us use a line graph to look at the results visually. So we're going to select our data set, click on the Insert tab, and from under the line chart, let's select line with markers. Let's increase the size. And of course, with any chart that you generate in Excel, you can choose a design that you like. Now again, because we're using the random function, every time you click on the function itself and you press enter, the values tend to change, and you'll notice the change in your line graph as well. Since we're talking about pens here, let us remove the decimal place and make it the next whole number. So this is one way to simulate demand in Excel using the norm inverse function and the random function. Since we are using the random function, every time we click on the function and press enter, the values tend to change. Now let's do that a few more times. The model appears to be working fine for most of the times. Sometimes we can get demand that is negative. As you can see for year 7 here, the demand is showing up as -8.
Now this could be because we are calculating our simulation based on the demand of the previous year.
So here in column C, you can see that here I have more negative numbers than positive demand numbers. So now one way to fix this is we can modify the model a bit. What we can do is we can make the mean and the standard deviation move together. So in year 2, we're going to start typing equals to NORM.INV. We're still using the random function. And the mean, as per the question, is the demand forecast from year 1, comma, as we said, we're going to make some change to the standard deviation here. So in place of just putting the standard deviation as 1200, we're going to type in 1200. I'm going to do self-referencing here, and I'm going to lock this by putting the dollar signs so that I'm able to copy and paste the formulas. Okay, so then after that, we're going to multiply that. So in Excel, you use the asterisk sign for multiplication. And we're going to multiply that to the forecast from year 1 divided by the original mean, which is 4,500. So I'm going to lock that as well so we can copy and paste the formulas. And close bracket. So recap, we typed in norm.inverse, we inserted the random function, and after that the next argument asks for mean, and we inserted the year 1 demand, and comma, in place of just typing in the standard deviation as is, what we did here is we inserted the standard deviation multiplied by the demand from year 1 divided by the original mean. Now let's drag and drop. Okay. Now let's try this a few more times. Positive number, positive number. So you can try it in your model as well. So this is our second model. It appears to be working fine. So this is model 2 and this is model 1. So to a certain extent, we have successfully reduced the likelihood of a negative number being generated for demand by using model 2. But model 2 is not foolproof. There are still chances that negative values will show up. So we're going to try the third model. So before I do that, let me do a little bit of formatting. Okay. I'm going to move my chart to the right. So we're going to do model 3 calculations in column E. So in model 3, we're going to assign a non-negative number, for instance 100, and we're going to set that as the minimum demand amount. So let's go ahead and write our minimum demand allowed figure right here, so we can insert it into our formula. Now in Excel, we're going to use the maximum function in combination with the norm, inverse, and the random function in order to insert this minimum demand allowed number. Okay, so for year 1, our function is going to look like equals to max, and you can double click when you see the function. You're going to insert the norm, inverse function, and the rand function. So these look similar to what you did in the first 2 models, except here you have inserted the max before the norm inverse function. Let me use the formula bar here, comma. Mean for the first year is the original mean, so 4,500, comma. Standard deviation is the original standard deviation, which is 1,200, close bracket, comma. Now for the maximum allowed number, we chose 100, so we're gonna keep that, close bracket. Now we're going to move on to the calculation for the second year. The calculation for the second year is very similar to what you did in model 2, except here you're going to insert the maximum value allowed, which is 100. So let's go ahead and build our function. So equals to max, open bracket, norm, inverse, and then the rand function. Now for mean, we're going to insert the demand from year 1, comma. For standard deviation, instead of just inserting the standard deviation as is, we are multiplying that to the demand for year 1 divided by the mean. Now let's do absolute cell referencing so that we can copy and paste the formulas to the rest of the cells. So here after the rand function where you have mean, that's fine, you don't have to do absolute cell referencing on that one. But for the standard deviation, you don't want that value to change, you want it to be always 1200 multiplied by the demand for year 1 divided by the rest. So let's go ahead and first absolute cell reference the standard deviation value. Now let's see, I'll use the formula bar right here. So we are multiplying that to the demand for year 1 divided by the mean. So the mean should not change as well. So we're gonna do absolute cell referencing on that one too. Okay, so let's close our bracket and let's finish our maximum function. So for that again, I'm going to select the cell and do absolute cell referencing. So let's recap what we have done here. So for the second year, we are combining the maximum function with the norm inverse function and the rand function. And the first argument after the random function is your mean. Mean is the previous year's demand, comma. Then in place of standard deviation, you're going to do the standard deviation multiplied by the demand for the previous year divided by the original mean. Then you're going to close the bracket and insert 100, or you can do cell referencing. Now let's copy and paste the formula. Okay, so let us round up our numbers for model 2 and 3 and make it the next whole number. Okay, so making the maximum function part of your normal inverse function and the random function helps prevent the demand forecast or the demand numbers from being negative. So in this video we looked at 3 simulation models to generate demand.